This week, we wrap up our analysis of gridded Mesonet data by calculating Q vectors to find frontogenic and frontolytic zones. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. Over the last 2 weeks, we've learned how to download Mesonet data, regrid that Mesonet data to our regular grid spacing, and then make some nice contour maps. We even looked at how to calculate gradients, so not only could we see a front in these tight groupings of contours here, but we could also find the front using a gradient, either directional or total. This week, I want to wrap up by calculating the Q vector. The Q vector generally points towards upwards motion, so if we see a Q vector pointing into warmer air, it's a frontogenic zone, and if we see a Q vector pointing into cooler air, it's generally a frontolytic zone, or a weakening front. Now luckily, MetPy has the Q vector calculation built in. We just have to give it what it wants, and we've done a pretty good job of preparing for that. So our Q vector is from mpcalc.qvector. And it's always good to look at the docstring. Here our docstring tells us that we want the U and V components of wind, temperature, and pressure. And we can give it something about dx and dy, which we're going to approximate. We've already gridded the wind, but we need to make sure, since it's a calculation, it's going to expect units. It's going to assign units of meters per second. Our V component of the wind, also in meters per second. Next was temperature in degrees Celsius. Pressure in hectopascals. And then comes our dx and dy. Now, again, we really just worked in degrees here. We didn't reproject everything to some UTM coordinates, for example. So we're going to approximate. We're looking over a relatively small area, and we know that a degree of latitude is 111 kilometers. So a tenth of a degree, which is what we've gridded to, would be 11.1 kilometers. And longitude, well, that changes whether we're close to the equator or close to the pole. We're at the mid-latitudes here and over a very small range of latitudes. So we're going to assume that 11.1 kilometers is pretty good for the state of Oklahoma. And this is going to give us a multidimensional array with U and V components. Just to make things easier on ourselves when we're making a plot of this, I'm going to go ahead and break it out into Q vectors 0, and we'll drop the units. V is Q vectors index 1, and we drop the units. And that's because I called it Q vector. There we go. It's always a good idea to get some order of magnitude of what we're looking at. We're looking at very small numbers here, times 10 to the minus 12, 10 to the minus 13. So there might be some scaling we need to do to our plot, something to keep in mind. Now let's go ahead and get our plot from up here. I like this plot. I just want to add to it now. After our contours, I'm going to use a quiver plot. If we look at the documentation for quiver, it takes the x and y position and then the u and v components to plot this field of arrows. So we're plotting vectors on our map, which this is a vector. So I've got grid x, grid y. Use our tab complete, q vectors u, q vectors v, and let's make our plot. Okay, so what happened? We don't see them. Well, we can't forget that we need to tell plot what our transform is. We're working in our data coordinate reference system, which was just lat and longitude. And our map is not in that coordinate reference system. That should just be transform. Okay, now we've got a vector field. I can't really tell a lot about it yet. These are all pointing into warm, so that would mean this is a frontogenic zone. That makes sense. But they're a little larger than I would prefer them. So we can use the scale argument. A great thing to do is, well, one, read the documentation, but two, also just start playing with it. So I'm going to set scale to 1. Let's see what happens. Well, all the vectors are tiny. Okay, what if I set scale to a very small number, like 1 times 10 to the minus 18? Okay, now the vectors are all very large. So you can play around with this to get the look you want. 3 times 10 to the minus 9 was a scale that I liked, because it makes all of these small vectors almost invisible, but we get this nice representation of where our frontogenic zone is, all these Q vectors pointing into the warm air. So I hope that you found this useful, seeing how we can take data from its raw form to a gridded form that we can then do numerical computations on and create plots from. I'll see you on next week's MetPy Monday.